And continuing in our content production theme, we now turn to the intersection of AI, video, and public service collaboration. Mikaela Åstrand, AI ML engineer at SVT, and Leonora Vesterbacka, senior data scientist at KBLab, National Library of Sweden, will present a tool for AI-based video subtitling developed in a unique partnership between Sweden's largest broadcaster and its national library. Please welcome Mikaela Åstrand and Leonora Vesterbacka.
Okay, everyone. Hello. Nice to be back here. I was on stage here 2 years ago talking about slightly similar topics, but not really. So we're going to talk about utilizing captions to improve speech recognition. So the first question is, why do we need to improve speech recognition for Swedish? This is us. We were already presented. So the first thing is we use speech recognition or transcription, as we heard, in several different parts of the journalistic workflow. You heard a lot of examples already today, although we're just halfway through. So transcribing interviews, really cumbersome to do manually, easy peasy if you do it with automatic transcription. Finding whatever you might be looking for in the archive, if it's audio or video, it's really hard to search for. It's a lot easier if you can transcribe the content and search in this text. And then finally, the main application we'll talk about today, which is captioning and subtitling. And the other question is, do we need better models? Aren't they good enough? This has been around for quite a while. Speech recognition is not something new. But we've been working with automatic captioning at SVT for a bit over a year, and we keep seeing various silly or more or less good errors. So it's really not good enough. But we're not the only ones in Sweden interested in improved Swedish speech recognition. We found out that KBLab, National Library of Sweden, were looking into similar topics, and that's a perfect area for collaboration. So I'm going to hand over to you.
Thank you. In order to improve these models, we turn to the National Library of Sweden, where I work as a senior data scientist. The National Library of Sweden is responsible for collecting, preserving, and giving access to nearly everything that's published in Sweden. So this includes newspapers, books, and this stems from a legal deposit act from 1661 that required all printers to deliver one copy of everything printed to the library. So we don't only have text-based material, we also have huge audiovisual archives. So for example, everything that's been broadcasted in Sweden, so TV and radio. And this is the type of archive you need in order to improve speech recognition, because this contains millions of hours of spoken Swedish. So far, I don't think we've mentioned the word AI in this talk, but this is, of course, fully AI. This is speech technology. It's had many names over the years, but this is 100% all AI. The act of going from a string of words to a waveform, that's speech synthesis, so when you synthesize speech. And if you go from the other way around, from a waveform to transcription, that's speech recognition, and that's what we'll focus on today. And we're going to talk about the Whisper model from OpenAI. Some of you might have heard about this if you use it in your transcription tools or something. This is a model that was released in 2022. It's an encoded coder transformer model, for those of you who are interested in the architecture. It comes in 5 different sizes, where the tiny one, as you'll see later on, is useless in Swedish. It's nice and handy, small. You can download it on your laptop, but it's really, you can't use it. The large one is good, but it requires a lot of compute to use it. So these models have been trained on 680,000 hours of multilingual speech. And this terrible plot here is showing a lot of different languages. So first of all, the blue box here is representing 65% of the training data, which is in English. And then 18% is translated material. And then only 17% is multilingual, so all of the other languages. And Swedish is 2,119 hours. So this is less than 0.5%, and this is reflected in the performance of the model. So what we've done at the National Library of Sweden is to take this base model that have the knowledge of all these different languages and construct a new training data set together with the Swedish television, consisting of 50,000 hours of Swedish training data. And then we perform a so-called two-stage training approach, where we first give it this larger data set and then further fine-tune it into either learning how to caption or to transcribe more verbatim. And these we call KB Whisper, because KB, Kungliga biblioteket, is the National Library of Sweden. The training data for these types of models is an example of speech, a waveform, paired with transcriptions. So when we started this project, almost 2 years ago now, we turned to our own archives, because we have a lot of TV, and we hope to extract Swedish speech from TV paired with subtitles. This proved to be a bit more difficult than we thought, because not all the formats were in the form we wanted it. So around the same time, we were invited by Mikaela and her team at Swedish Television to participate in this tech sprint that they had in August 2023. There we together elaborated with fine-tuning a whisper model just on the subtitles from SVT. So this was, we had already at the National Library had experience in training these models, and Mikaela and her team came with the data. And the results were very promising. So this kind of led to a longer collaboration together. So we have participated in getting data from them, but we've also received data from the Swedish Parliament. So the Swedish Parliament is responsible for also recording everything that's said in the Parliament, so all the debates and everything, and then also provide high-quality transcriptions to it. So this has been going on since 1966, and we were the only other ones that got access to this, this hard drive full of audio files from 1966. And then we matched all these old audio files with protocols in PDF form, which was like a combinatorial nightmare to kind of make sure that was correctly done. And in the end, this resulted in a training data set with 23,000 hours of high-quality Swedish transcriptions. So we've used this and many other different data sources, but I don't think we have time to go through it. But we did this two-stage approach in the training, and we've released all these models on our Hugging Face page. I hope some of you tried it. Otherwise, please go ahead and download it and try it out. There are many web applications where people have built their own applications with our models in the back, so you can try it. And I guess the most important question now is it any better? And we evaluate the performance in terms of word error rate, which is a sort of metric that is used in automatic translation and for these purposes as well. For this metric, the lower value is the better. And here I'm showing you the 5 model sizes, tiny to large, comparing the 2 different organizations. And we can start by looking at the tiny model, and also we evaluate on 3 different standard evaluation data sets so that we can actually compare with what OpenAI wrote in their paper. And here you can see that for the tiny model, this 59, 67, 85, those are terrible values, and it's reflected in what you see when you use these models. You can't use it, it's just gibberish. We've took the performance down to around 12 in the word error rate, which is the same performance you get for a large model. However, this is a much smaller model, so it enables usage across many different domains by just people can use it on their phones, which was not the case before. And then most notably, the improvement in the large model amounts to 47%, evaluated over the mean over all these evaluation data sets. But I think Mikaela has some more examples of how this is better.
Yes. So then back to the use case of captioning with KB Whisper. The first question we ask ourselves, is it any better also on our data? Like those were the standard benchmark data sets. It might not correspond to exactly what we want to use it for. So we did some comparison on manually transcribed audio from various programs from our archive and compared a bit more than just this, but I'm going to show just those numbers. So the current default Azure model for speech recognition in Swedish, KB Whisper Large in this case, and the original Whisper Large. And we also evaluated on Tiny and saw similar results to this. But so the first thing would be word error rate, as Leonora mentioned, where lower is better. I just realized I used a different scale, so it's going to be between 0 and 1 instead of 0 and 100. But lower is still better. And we evaluated that on the normalized text. And we got those results. Where it looks like KB Whisper is the least good one. That's not super uplifting, maybe. But then if you look into the details, because word error rate, it tells you something, but doesn't tell you everything. We had our own metric that we called word list error, where we have manually picked all the names, various important words, more difficult words like long composite words and so on, and evaluate specifically on those. Are they correct? And we see that KB Whisper gets it wrong less than half as often as Azure, for instance. And that was one of the main motivations, as we saw in those examples previously, like names are often wrong. With KB Whisper, they're a lot more often correct. So that's nice. One of the differences is how those models work. So the manual transcripts we compared to, they are trying to be as close as possible to what's being said, removing like disfluencies and if I would say those kind of things, but still it's like word by word what's being said. And Whisper has now, and KB Whisper specifically, has been trained on a lot of subtitles and captions, and that's not how that text works, right? It's a written representation of what's being said. It's summarized, it's condensed, it's corrected, and so on. So we would expect the output to be a bit more similar to captions, kind of. And so if we look at like verbosity, where here one would be that we get the same number of words in the output from the model as in the manual transcript. So it's like word by word. That's roughly what we get with Azure. With KB Whisper, we get a lot less words. So it's a lot more restrictive in the number of words it's outputting. And if we then look at those words and we see how many of them are correct, it turns out that a lot more of the words are actually correct. So the words that it's skipping some stuff, but what it outputs is more often right. So just a short example of what it could look like in captions. Here is just a super short snippet where we see difference in names, how they're spelled, if it's correct or not. But also, in this case, the host, she started saying something, she hesitated, she started over saying the same thing again. And Whisper kind of removes that repetition, so we only write out those words once instead of twice. So that's like a typical difference. I'm going to show a small video clip. I hope the audio will work. It's in Swedish, obviously. It's going to be really fast. It's half a minute, where we see some of those examples. But we can't show everything, obviously. Half a minute.
This is Whisper, and that's Azure. Yeah.
Exactly. And let's see if it works. I don't know. No, it did not. Is it possible to play from behind, or? There's usually a small play button somewhere. It says QuickTime not available. That's not great. Yeah.
Well, you can already see that KB Whisper got Dostoevsky right in Swedish. So I think that's the main take-home from this.
Yeah, there is another difference. He didn't say something at the end that last night. She was forcing me to read. It was not Dostoevsky forcing her to read something. And so on. Okay, we're going to skip the video. That's life. So just a few words at the end. If you want to do it similar, you have some kind of need for training something. You might have plenty of data that you think would be useful for this, but you don't really know how to do it. First thing I would advise you to do is to involve your legal department early. It might take a bit of time. They might say okay to a lot more than you would have thought, or the other way around. It's good to clear those things out early in the process. Second thing, as Leonora was saying, with the parliament data, they had PDFs and they had hard drives and no mapping between them, and it's a big work to try to figure out what belongs together. We had a bit better order on our metadata, but it was still slightly restricting what we could use and not, because we didn't have the link always. So good metadata is always key for identifying what material you could use for your training. And if you don't already have it, then whatever you're producing today is the training data of the future, so better start now. And then finally, at SVT, as well as in a lot of your media organizations, we maybe don't have the computational resources we would need, maybe don't have the expertise or the experience, but there might be others that do and that have similar needs, and you have the data. So find good partners to collaborate with. For us, that was KBLab. For someone else, it might be someone else. But then when you do so, try to be involved in the details so that next time you're better prepared yourselves to do this without depending on someone else. And as Leonora said, you can find Kobe Whisper on Hugging Face, so try it out. That's it for us. Thank you.